Imagine a state where nothing exists. No Earth, no sun, no galaxies, not even empty space or time as we understand them. Then, nearly 13.8 billion years ago, a sudden, incredibly hot and dense state emerged. It is tempting to picture this as a giant explosion going off inside a dark room, but there was no room. This animated diagram represents how space itself expanded, stretching the very fabric of the universe outward. As the universe rapidly ballooned over the eons, the extreme heat dropped. That cooling process allowed raw energy to transform into the first physical particles, eventually forming matter. We can actually detect the remnants of that early heat today. This image shows the cosmic microwave background radiation, a map of microscopic temperature fluctuations that scientists consider the baby picture of the universe. But expanding space simply pushed things apart. To actively gather that early matter and build structures, the universe required an invisible architect. That architect was gravity. By pulling enormous clouds of cooling gas and dust together, gravity gathered mass against the outward push of the expanding universe. Inside the core of those collapsing clouds, density and heat spiked. This diagram shows what happens next. Hydrogen atoms violently collide and fuse into helium. That nuclear reaction releases enormous energy, and a star begins to shine. Gravity then herds billions of these newly ignited stars together, binding them into massive, rotating cosmic cities known as galaxies. Over millions of years, the most massive stars exhaust their fuel. The core collapses inward, triggering a violent, spectacular shockwave known as a supernova. Stellar death is an essential mechanism. The immense pressure of a supernova explosion forges heavy elements like iron and carbon, scattering them across space to eventually build planetary bodies. About 4.6 billion years ago, a specific cloud of gas and dust collapsed. The dense material at the center ignited to form our young sun. In the rotating disk of debris left behind, particles constantly collided. Dust stuck to dust, forming clumps, which merged into larger planetesimals in a process called accretion. Near the young sun, temperatures were blistering. Only dense rocky material and heavy metals could survive that heat, gathering together to form the inner planets. One accumulating rocky body was Proto-Earth. It was a terrifyingly hot, violent world, kept entirely molten by constant bombardment from space debris and gravitational compression. Because Earth was entirely molten, its self-gravity pulled the heaviest materials downward. Huge amounts of iron and nickel sank to the center, establishing a dense metallic core that still drives our planet's geology today. A Mars-sized protoplanet called Theia violently crashed into the young Earth, tearing a colossal chunk of rocky material straight out of its mantle. The sheer force of the impact blasted enormous amounts of superheated debris out into space, leaving it in a chaotic, spinning orbit around the planet. Gravity went to work on that debris field. Over time, the orbiting material clumped together, merging and cooling to form a single spherical body, our moon. Because the newly formed moon has less mass than Earth, its gravity is too weak to hold on to a thick atmosphere. Without wind, rain, or a protective gas layer to burn up incoming meteors, every impact leaves a permanent crater on its surface. The collision that nearly destroyed Earth ended up stabilizing it. The moon's gravitational pull locked our planet into a steady rotational rhythm, anchoring the conditions needed for our world to evolve. Millions of years passed. The cosmic bombardment slowed. Earth's surface cooled to form a solid rocky crust. Massive oceans collected, and distinct protective shields wrapped around the planet. Meanwhile, the Earth and Moon settled into a stable orbit. This diagram illustrates how that actually works. The Moon is continuously pulled downward toward Earth by gravity, but it moves sideways fast enough that its curved path keeps missing the surface entirely. This photograph shows what happens when their orbital paths perfectly align. During a total solar eclipse, the Moon slides directly in front of the Sun, blocking the intense central glare and exposing the incredibly hot outer atmosphere known as the corona. We can also see the effects of Earth's dense metallic core in the sky. The core generates a magnetic field that deflects charged solar particles. As this image highlights, When those particles strike the upper atmosphere near the poles, they produce the vibrant streaks of the auroras. The iron in our blood, the ground beneath our feet, and the sky above are the direct result of a 13.8 billion-year chain of events. Expanding space created the canvas. Gravity built the structures, and dying stars forged the materials for a small blue planet to finally emerge.